like to kick off this Global Networking Forum. It has already become tradition that on the last day of our International Astronautical Congresses, we are organizing a Global Networking Forum involving space flyers, astronauts, our traditional astronauts GNF. And we are extremely pleased to also this year will be able to offer this to you. And I see so many people here who were coming here in also for the public day. So please enjoy this excellent lineup of space flyers. The title of this GNF I considered quite provocative, but I think that is stimulating the discussion. No risk, no fun, keeping human spaceflight safe. That's the title. And you will be able to ask your favorite questions by using our Slido system. You know it already, hashtag IEC 2024. Please submit your questions. And it is now my great pleasure to introduce somebody who has been instrumental in setting up the closest cooperation between the Federation and the Association of Space Explorers, which is an organization that brings together all the flyers. Reinhold Ewald, astronaut and president of the Association of Space Explorers and now also chair of the IEF Astronauts Committee. And it's my great pleasure to introduce him to you as your moderator for this session. Please give him a round of applause.
Thank you, Christian, for the very kind introduction. And he has almost, or he has certainly more than 50% of this idea. And I owe him every credit for this. So let's start with a session that would look into the obvious thing. If you come to a launch pad early in the morning, the rocket is already fueled, you will immediately have the feeling this is a risky maneuver that we are going to see soon. But the rocket and the gases streaming off the rocket, the kerosene, the hydrogen, the oxygen, that are only the visible signs of a risky maneuver about to begin. The spaceflight is still in a phase where you don't do it routinely. You always are aware that untested things may go wrong, even tested things may go wrong, that you have to anticipate, to improvise in space in order to make it safely home. And how you do this and what are the thoughts of the persons involved, because we are talking about human spaceflight today, that we want to clarify in this panel. And please make good use of the slido.com possibility to ask the questions to the podium. So I now would like to call to the podium the experts of today's panel, all with their own experience. And the first and I think most prominent alone from the body height of this Congress is Luca Parmitano. Luca, take a seat. The next in line is Tony Antonelli. And with a very special experience, Tuva from Turkey. We are a 3G Congress, so we try to balance at least a little bit. It's always a deficit in spaceflight to balance the gender representation. So it's a great pleasure to have Antea Comellini on the stage. And what would such a panel be without Aki Yoshide? Last but not least, Eitan Stibbe. And You can see that we are generation-wise quite connected, Aiton. So I will introduce the speakers for the first round of questions. And the first question I will do from my seat here. The question is, yeah, thank you. The question is, I talked about the obvious risk, but there are hidden risks. What your personal, in your personal judgment, what was the moment where you were most scared, despite all the fun that we have preparing for a space flight, but where you really thought this is not in the plan, and I should better get my thoughts together in order to make it home safely. So first, to answer that question would be, oops, I'm too. Yes, I get the answers. It's Luca Parmitano. Luca Parmitano from Italy. He graduated from the University of Naples. He's a test pilot with over 2,000 hours by now, I think, and 40 types of aircraft. Amazing. Yeah. A colonnello. That sounds in Italian much more nicer than in German. He has flown Expedition 36 and 37 on the Soyuz TMA, up and down, and the Expedition 60 and 61 on the Soyuz MS, so 2 vehicles. Maybe there's an impression. He has scored 366, almost 367 days in space. Huh? You could have delayed your landing a little bit.
I tried.
6 EVAs, that makes him the record holder of EVA still in...
Actually, in numbers, Thomas and I have the same number of EVAs. Yeah, we have the same number.
Yes. With 33 hours outside, and now he's on ESA collateral duty. Luca, scary moment, let me guess.
Yeah, being up here, it's actually one of those moments. Right now I'm wondering, what the hell am I doing up here? So, I hope not to disappoint you guys, but I completely separate risk and fear. Those are two things that don't belong in the same bag for me. And I have a sense that, Tony, you would agree to that. If you are an operator, and by operator I mean somebody that picks a career in an operational field, be it on the field, be it in the air, as a test pilot, as a fighter pilot, risk is a component of our job. However, what is fear? That is the question, because your question is very specific. What is the scary moment? What is the moment where you are afraid? Scary moments, there are a lot. What are the moments where I'm afraid? That is a different question, because fear is a natural reaction. It's a functional, a physiological reaction to the unknown. So when we have to deal with something for which we are not prepared, we feel fear. And the physiological reaction is the sweat, the pulse accelerating, the adrenaline running through our body. But the main subject in all this sentence is the unknown. When we are small kids, and I saw some small kids out there, when we are small, when we are children, we are afraid of opening the door into a dark room and entering into the dark room. It's primordial, because we don't know what's in the dark room. We don't know if there is a hole, we don't know if there is an obstacle, we don't know if there's a monster, right? That fear prevents ourselves from putting in position of danger. We don't want to die, and our body tells us, you don't know what's out there, so don't go into the dark room. It's primordial. So, what's the easiest way to overcome that fear? It's to turn on the light. The moment you turn on the light, whatever is in that room appears. It could be an obstacle, it could be a hole, it could be a monster. However, together with the light and the darkness, fear disappears, because at that moment, once you have clear what's in the room, whether it's the obstacle, the hole, or the monster, Now it's a different problem. It's no longer an unknown, it's an actual problem to solve. So if there's a hole, you have to go around it. If there's an obstacle, you have to jump. If there's a monster, you probably want to run away. But it's no longer fear, it's a problem to solve. So why do I say the risk and fear and my job are not in the same construct? It's not in the same Venn diagram. Because astronauts turn the light all the time. The light for us is always on. We study for our entire career, before, during, and after, to overcome the unknown. We study so that we know our systems. We study so that we know our capabilities. We study so that we know the capabilities of those that surround us. So it would have been very easy for me to say, oh, the scariest moment in my career was flying on the AMX and hitting, having a bird strike that almost destroyed my aircraft, or saying, when my spacesuit failed in the middle of my EVA. That's the easy answer. But I would be lying to you, because fear is not a component of those events. Risk is, but not fear. The reaction, the resolution of the problem, that is what we do in our training. We spend hundreds of hours training, hundreds of hours, months, years training to turn on that light into the dark room. And so for the kids out there, when you hear your parents and your teachers and everybody around you, the society telling you, study, read, travel, invest your time in knowledge, it's because we want you to go into life without fear. The more you know, the less you fear. Knowledge is the antidote to any fear, is the light that turns away the darkness.
Thank you. Time to introduce Dominic Anthony, called Tony Antonelli. Obviously, there is some Italian connection in your family, but he's from the USA, as you can see on his shoulder. He graduated from MIT and the University of Washington. He's a naval aviator, a test pilot with 3,200 hours, so and 41 types. So he beats you in this. Yeah. He has flown on STS-119 in 2009 and STS-132, both in ISS assembly missions, and he's now with Lockheed Martin, responsible for advanced programs of civil space. Tony, what is the risk component that you became aware?
So I have my scariest answer. I'll get to that, but I hadn't broken up risk and fear. So it's obvious I'm not as handsome as Luca, but y'all also didn't know I'm not near as good as answering questions either. So I'll be quick so we can hear more from Luca. But in the human spaceflight world, we talk about risks all the time, less so in your day-to-day. Though for me, the way I would separate risk is it's on one side of the scale, and the benefits of what you're trying to do are on the other side of the scale. And whether or not you're consciously making these trades as you go through your day, some folks smoke cigarettes. I don't know if anybody's told you. Some of the docs have said that's not so good, but you're making that trade to say, hey, whatever you think the benefits are worth better than the risks. I don't know how much here, I haven't noticed too much, but in the United States, folks drive their cars and text, which is trading their risk level, and I got to believe they think the benefits are worth it. I didn't get to vote, but I'm not sure I'm a fan. So that's how I separate risks. For fear, I'm not a big fan of heights, nor public speaking, but so the scariest part for me was at the launch pad when the elevator doors open and you have to walk out over this open steel grating to get to your space shuttle. So that was scary for me.
Yeah, and then it subsided with 2,000 tons of fuel underneath you.
Yeah, it transitions to like really fun, but I thought you were going to let me off the hook. I was done talking, but you don't get to pick your fears, right? You just show up and you're afraid. I'm going to go back and reflect on Luca's comments ago, maybe I should study more. Maybe I can control them better. But right now, often I show up and I'm either okay or I'm afraid. What I've learned through flying airplanes for the Navy, if anybody's landed a airplane on an aircraft carrier at night, that's terrifying. So I do know what like being really scared feels like. Um, but I think you just show up and you're either afraid or you're not, and whether you're going to concentrate and do your job is completely within your control. So if you have fears today, but they're in your path to doing something that you want. Oh, by the way, I'm not the only one that's flown in space that's afraid of heights. So if any of you are afraid of heights, you can still fly in space.
That's good news. Next in line, Tuva Atasavet. He's from Turkey. He graduated from Beacon University and University of California in LA, San Francisco, Irvine. He's an engineer by profession, and he had a double chance this year. Amazing. He backed up Alper Gizarafci in the Axiom 3 mission and was almost next to the launch pad in this respect. But then he had a chance to go on the Virgin Galactic flight number 7 in June. It was 15 minutes of space experience. Tua, did you feel that the safety briefing that you get in such a high-flying vehicle, that it was sufficient for you to cope with whatever unknowns would be happening?
Well, if you're referring to the safety training we got during the flight week with Virgin Galactic, that was a surprising thing compared to the training we got at Johnson Space Center, which was 8 months long training, both theoretical training in terms of against certain emergencies that we can encounter on the station, ammonia leak, pressure leak, or fire, or medical emergencies. We would get theoretical training in the classroom, a comprehensive one. Then we would go into this beautiful place that we all love, called Building 9. That's where the mock-ups are, right? Whenever I went to that place, I felt like I was a kid in a candy store, that I could go inside of the mock-ups and pretend that I'm a spaceman, right? Just playing with those interfaces and learning. And we would go to those locations, to those mock-up facilities to train and carry out simulations, as Luca mentioned, hundreds of hours, right? We would do each and every emergency scenario. They would just throw certain stuff at us and watch us behave and carry out the procedure as expected. The Virgin Galactic side was completely different because their approach and their aim is quite different. Our entire training was just a week. It was slightly longer for me because I had payloads to fly, but the other private astronauts, they would just show up 4 days before launch and go through the entire thing in that 4 days, including every single thing that they need to learn about the systems, the emergency activities, and also, unlike Falcon 9, which has this escape abort system that would sort of carry you away from the risky aspects if something was to go wrong in the rocket, in the booster. If something was to happen in the Unity during our flight, we had parachutes on, and we would need to just jump out of the aircraft or the spacecraft to be able to survive. Given that operational scenario, the training we got, I don't know if I'm allowed to say that the amount of training we got from Virgin Galactic, it was a shock to me, right? The amount of emergency training that was given. Yeah, exactly, yeah, right, exactly. Just right before takeoff, just do this. Of course, they probably rely heavily on the pilots. That we had 2 pilots on board amongst 4 flyers. They, I'm guessing, heavily rely on the pilots to execute certain emergency activities. But what if one of the pilots are incapacitated, right? In my mentality, I should be as prepared as they are in the case of emergency to act upon them. So it was a different approach from the perspective of 2 different spaceflight experiences and trainings that I got. But one thing that is maybe worth mentioning about fear and how to overcome fear, during our training, L-4, we had an aerobatic flight that we went on to both experience some heightened Gs, some high G maneuvers to get our bodies familiar, and also some reduced G maneuvers. We would do parabolas, and I had some payloads on me, so we wanted to test them out before flight. The aircraft that we flew on was called Extra 300. It's I think, the German-made aircraft, very fun one, and to maneuver and control. And it's an open canopy, right? You see everything around you. And the pilot of the craft, so I'm up on the front, and Jamil Janjua, the Canadian astronaut of Virgin Galactic, we were together in the aircraft. We did our first parabola just for me to feel, right? Because up until that point, I had not experienced the reduced gravity. So I didn't want to do anything with the payloads, but just to feel that reduced G. I don't call it the 0G or micro G because you're still in the atmosphere. Your engine is, even it's in the idle mode, it's still running, but it's 0.1 Gs maybe, something like that. So you go up, and all of a sudden you're falling down. You're falling down, and I could see, because of the canopy, the ground coming towards us. It's not too long with that aircraft, with the altitude that we were doing those maneuvers, 12 seconds, something like that, but you could actually see falling. But interestingly, that was one of the most serene moments of my life. The reason, of course, this reduced gravity has this sensation, that tranquil essence to it, but also I really trusted the guy sitting behind me, right? I knew that he had my back. I trusted him, just like I learned how to trust my crewmates from the AX3 training. So one of the ways in which that we beat fear in case of emergencies is trust our crewmates as well. And learning that was a huge, huge gift for me throughout this training. So, yeah.
And just a short question after that. How important was it during your actual suborbital flight to have payloads that you operated? Would you have done the same thing without payloads?
You mean take the flight without payloads? Oh yeah. I would take the flight tomorrow with no questions. But of course, carrying out research was important for our mission. As part of Galactic 7 mission, we had 7 different experiments, 3 of which I took to space, and I had to carry out certain operations on each and every one of them. This is all to grow the space science and space research in Turkey, so that those first steps that we took, the next generations, the next researchers are going to be imagining things that are more involved and evolved and more interesting in the years to come. So it was a very important and integral part of our entire mission.
Yeah, thank you. Antea Comellini, Italian. She graduated as a PhD from the Sub Aero in Toulouse, so your French is also excellent. In this, you're an engineer with Thales Alenia Space, and you have also stints with ESA as a space navigation engineer. And then ESA kind of recruited you as the reserve astronaut in 2022. And it's good to know that you will have upcoming training at ESC. That's a great place to start your astronaut career. When I remember putting an envelope at that time, no email, envelope with my application for the astronaut job into the mailbox, a couple of months later, Challenger exploded. And that brought me to the idea, do I still want to pursue this, or what I did there? But in the end, I decided that we also learn from these kind of accidents. We have to learn. We are, as responsible people, we have to make good for the errors that are mistaken, and I continued. How, in your case, were you treating the thought of going on to something risky later in your astronaut career?
So for me, this one was a question that I asked myself really when the selection was announced, because at that time I've been studying and working in the space sector for quite a while, so I was more aware of what were the risks and the fact that actually we cannot control all of them. I mean, we can try to design for minimum risk, control the hazard, add failure tolerance, but there are still things that we cannot control. Like, for instance, one of the main drivers of the loss of crew probability is actually debris and micrometeorites. And those ones, we cannot control them, and we cannot reduce the probability about them. It's only going to increase, actually. So yes, I've been asking myself this question. Actually, the day they announced the selection, I really tried to picture myself on a rocket. So thinking, okay, I went through all the selection and I went through the training. Do I really want to do this? And this question actually was also asked by each one of us, I think, also my colleagues, Carmen and the other, by the Director General. So when there was only 27 of us, so we were very close to being selected, and we could start feeling that things were getting real. And if you have the Director General of ESA looking into your eyes, and it looks like he's looking into your soul, not your eyes, when you're doing the astronaut selection, and he asks you, but are you ready to die in space? And even though I had been asking myself the question so many times, at that point it kind of became real to me. And I was like, I mean, I'm not ready, but I am accepting the risk. And why I'm accepting that? For me, it's always a matter of cost versus benefits. And first of all, I am not risking just for the adrenaline. I'm taking controlled risk because the benefits are much higher. So I feel like I can contribute to the space program. I believe in the space program. I hope that one day I will be needed up there. And so I feel like I am ready to accept this kind of risk because I believe in what we are doing. And for me, that was the answer.
Thank you. And the honest answer. Turning to Akihiko's son. Akihiko Hoshide from Japan. He graduated from KU University and University of Houston. He's an engineer and started out in the NASDA, and then NASDA became JAXA, where he's still now. He has the experience of 3 flights and 3 vehicles. That's amazing. He delivered the Kibo second delivery flight with STS-124, and he was an engineer on Expedition 32-33 with its Soyuz TMA in 2012, and then became a crew member of the Crew 2 SpaceX flight for Expedition 65 and 66. He was a commander of Expedition 65 in 2021, and he continues with JAXA. Aki, after your first space flight, did you consider it valuable and responsible to continue, or were you sobered up?
So, yeah, great question. So, first flight, right after we landed at KSC on the runway, I immediately wanted to come back up to space. And I think we all share that same sensation. You were asking about scariest moments. So in hindsight, I think the scariest situation that we had was when we went out of attitude control on board the space station. Some of you may know we had an unexpected thruster firing on board the space station. That was during Expedition 65, and we started tumbling. We started going out of attitude. Usually, the station is flying, like that on with respect to the ground, but apparently we were out of control. And of course, the alarm went off, and we started working the problem. The ground was working the problem with us, and we managed to resolve the situation. Later, after we came back to Earth, we saw an animation, what actually happened. And it was fast forwarded, it was an animation, and it went like 540 degrees. So, you mentioned an acrobatic flight. Yeah, we did an acrobatic flight using the ISS. But were we scared at that moment? No, none of us were. And I think we were focused to resolve the situation. But at the same time, we knew that that kind of thing would happen. Again, it's about the risk, right? So we are mitigating the risk by, putting control so that it does not happen. And also, if it happens, we had procedures, we trained for it, we had ground controllers that are very skillful and knowledgeable about it. So all in all, that prepared us for that situation. So I think that's how we mitigated the risk. In hindsight, yes, we were tumbling, but we managed.
So training and trust.
Yes, absolutely.
Yeah. Turning to Aiton. Aiton, excuse me, but the difference between all these friends here and you is you paid for your flight, and they got paid for their flights. So for you, it was not a career decision to buy a space flight or to go into the adventure of a space flight. It was a very consent with all your thoughts, a decision that you took. What made you overcome the obvious feeling of why do I need to do something risky? You could have bought a holiday somewhere. Yeah. What was your balance, your assessment of risk in this moment? Excuse me, I should introduce you. You're from Israel. You're an Air Force fighter pilot, and actually, I think as a special feature, also you originated two funds: for the Vital Capital Fund for investments in Africa, and the Ilan Ramon Foundation. Ilan Ramon perished in the STS-107 accident coming back from space. He was the first Israeli citizen in space. And your flight was the Axiom 1 flight back in 2022. So, yeah, a new feature. And you called your flight Rakia, which kind of is horizon, firmament, these these things that point us into the back away from Earth. Yeah, 17 days.
Thanks, Reinhold. Ilan Ramon was my friend. He was the first Israeli astronaut who flew 2003 and unfortunately did not come back because the Columbia crashed in 2003. I attended his launch. We stayed in good contact with his family. And the narrative of human spaceflight in Israel was tragedy. So it took years until the opportunity came because the Israeli Space Agency did not consider to send additional astronauts. When the opportunity came and SpaceX opened the opportunity for private astronauts to fly, I jumped on the first opportunity with a good friend, Garrett Reisman, who trained with Ilan, and hopped on that with the intention to change that narrative in Israel, that human space flight is inspiring, can change the future of scientists, children, and excite people, build their curiosity about the universe, about our being here. So about one of the frightening moments, first was to step into Building 4S in JSC. Just be aware because you see Bob and Doug walking towards you, and it's a really interesting building because it's only astronauts, and they're speaking about going to the moon, coming back. But then on our way back, we had about 16 hours in the Dragon, circling Earth, and then they tell us, get in your suits, get in your seats. We're starting the deorbit process. About 420 kilometers above Australia, it takes about 20 minutes to reach Florida. So you start a few burns, the Dragon changes position, and it starts entering the atmosphere at 100 kilometers. And there you get the high G, about 4 or 5 G. You see flames in the window. And I knew that the Columbia crashed at 68 kilometers altitude, and I was looking through the window a little bit, but a lot at the altitude to see that we crossed that altitude safely. I had tears in my eyes, and not because I was afraid of my own life, but what I was doing, I experienced the tragedy of the Ramon family, and if I'm doing the right decision, it was a bit late, but to my family. So I want to say a word about trust, because there were not so many accidents in space, very few. And during the training, you learn to trust the whole system. You see how many people work for your safety, and they care about you. When you're a fighter pilot, the enemy is against you. When you're an astronaut, the whole world is in your favor. We trained at NASA, with JAXA, at ESA, and everyone wants you to go there and succeed. And succeed because failure is easy. There's so many expectations for you as an astronaut on board that you won't succeed to complete the experiment, time will go by, didn't practice enough, and you're really afraid of that. But the whole meeting with all these facilities that take care that astronaut lives are saved, and I'll just give you a few examples about the launch. So the launch pad, you go up that elevator, and there's a cable, like an Omega cable with that can take you if there's something on top of the tower. If something happens, you can just slide down. If they moved away the arm, the bridge, then the capsule, the Dragon, can eject and go up to 8,000 feet and go back to be saved. And then along the whole east coast of the US and the Atlantic Ocean, there are crews waiting if something happens after launch and you have to abort and the capsule will land somewhere in the Atlantic. They're all planned. So that gives you a sort of a security feeling and trust in the whole system that is helping astronauts succeed. Thank you.
Thank you. And now we are turning to the Slido questions. Don't forget to either vote for your favorite question to make it in the top, or put your own question. And we have an interesting question that obviously we have the experts here to give their assessment. We are seeing launches today where astronauts board the capsule before propellant fueling as opposed to the traditional procedure followed. What goes through the astronaut minds as tons of flammable propellant gets loaded underneath them? So the question is, what was the consideration to load the vehicle only after the crew has entered versus preparing it completely and then having the crew come? I remember my own flight on a Soyuz. We were approaching the launch pad, and a train was coming from the launch pad with a lot of empty wagons that had put all the kerosene and the oxygen into the tanks. So shuttle, I think, was fueled only after no. So then let's get the expert explaining.
So the shuttle was filled and reached stable replenish before the crew gets in. The Dragon's done it each way, especially with cargo. They would load it before, but the idea is the tanks are only so big. The colder you can get the fuel in the plant and get it into the vehicle while it's still cold, the more fuel and oxygen you can put in there, so the more capability you have. So they transitioned to that. They went through a bunch of reviews to make sure they could do it safely. But it's definitely the way to go if you want to take more stuff to space. But you don't know. You're just sitting there, right? You don't care. Do you? What's the worst that could happen?
Right. So, so Crew Dragon went the other way around, right? So, like Tony said, you used to fuel it first, like Soyuz is the same. So you fuel it first, and then the crew members get in. But for Crew Dragon, because the temperature is lower for the fuel, and also, you think about the thermal protection as well. So what we ended up doing was you enter, and then they fill up the fuel. So it's a reverse. Now, obviously, we had a huge discussion about that. They made sure that it was safe. We have controls in place, and you mentioned about the launch escape as well. So they make sure that the launch escape is armed prior to starting that process. So if something happens, we are able to punch off and save ourselves.
And here's one for the shuttle. While we fueled it ahead of time, right, we dropped the pressure down to get as much as fuel in as we can. And about a minute and 45 seconds before launch, we pressurized the hydrogen tank. The external tank of the space shuttle shrinks like 3/4 of an inch as they're filling it, and then it makes that up plus another 3/4 of an inch. And this aluminum tank has a better max fraction than your beer can, right? The weight full to empty is better on an external fuel tank for the space shuttle. And I never thought my beer can was over designed, right? But we decided to make it even thinner. And like you weren't even watching the hydrogen tank repress. So like if you wanted to be afraid of something, there was definitely something there to be afraid of, but
So
we weren't even watching.
fill it up, wipe the windscreen, huh? Luca?
Yeah, for the Soyuz up to this day, you can physically see that the Soyuz launcher is loaded with fuel before the crew arrives. Because if you go on the internet and look at the lifting of the Soyuz spacecraft, it arrives on a train. It's actually pretty spectacular. It arrives on a train and is laying down, and then they lift it up and they hang it onto its launch system. And if you look at it, it's completely green. It's the typical military matted green from Russia. It's like iconic. And then if you look on the day of the launch, you see the astronauts arrive, crossing the pavement to the elevator, and you look at the rocket and it's white. And I guarantee you that nobody went overnight to paint the spacecraft white to make it pretty. It's ice that has been forming even in the heat of the Russian desert, because we're in Kazakhstan. In the summer it can be quite hot, and what happens is that the cryogenic fuel is so cold that whatever moisture in the air forms ice on the fuel cells. So it's a demonstration that it's being loaded with fuel, and it's still being loaded with fuel. You see the overpress tanks releasing some of the extra fuel that's being loaded, and then the astronauts go up the elevator, which I believe is still the same elevator that brought Yuri Gagarin up 50, 60 years ago. That would probably be scary if you thought about it.
Yeah. I was
I
happy.
never-
I was
never
happy
thought
to
about
leave it. Yeah.
Yeah, I never thought about it. It's a
Yeah.
really small elevator,
Yeah.
and probably one, and very old, probably one cable. They probably didn't think about extra designs for safety about it. A couple of million people's personnel inside, and it's just this little cable going up. Didn't think about it until now. See why we're not scared? Because we don't really have enough brain cells to think about
Should
those
have been
things.
scared. Tuva,
But
Your-
anyway, yeah, it's still loaded. It's loaded before we arrive.
your vehicle was what? Empty, loaded?
So it's a different system using a hybrid. It's a hybrid rocket engine. So your fuel is not kerosene. It's something else. It's a solid, and you are sort of pressurizing and pushing a liquid onto that solid fuel. And the time we entered into the vehicle, it was all loaded. The solid is already installed, right, overnight, and the liquid oxidizer, if you will, it was loaded as well. So, and there were quite a lot of people around that hybrid rocket engine. One of the supposed benefits of hybrid rocket engines, the first one they always claim is cheaper, and the second one is safer. Then specifically for the solid fuel engines, you have the oxidizer and fuel mixed together. They want to separate them so that it's safer. And there was a lot of people sort of operating and helping us out get inside and be ready and happy and healthy to fly up. So it was all loaded for our flight.
But they were not Boeing engines, were they? Just a joke. We have another question here which I want to answer myself. How
Wait. Let Tuva finish his launch story, right? So he's got a very different launch experience than the rest of us. Are you getting your spaceship? It's
Yes.
fueled.
Yeah.
And now you're climbing up. Tell us about that.
So it's a different kind of profile, as Tony mentioned. It's an air launch system. We are traveling to the 14 kilometers of altitude, approximately, underneath a carrier aircraft, which they call Eve. We are sitting on it, essentially, with our spacecraft. And at that altitude, if everything is right, we are released. And that release is a huge bang, right? It's, I guess, very similar to a stage separation. It's just huge bang, and you're falling for 1 second. And you guys might have felt that if you're going through just a tunnel down with a huge speed, you just feel that kind of a...
And who doesn't like a bang and a drop?
Yeah.
I mean, no, you're in an airplane, all strapped in, bang, drop.
Exactly, yeah.
Everything is good. Awesome.
It feels amazing, yeah. For a split second, it feels amazing. And the moment that the rocket engine lights up, it just pushes you to your seat. That is the first shock. None of us in the cabin, we were expecting that much of power from that rocket engine. And yeah, we were in awe. The most spectacular aspect of our flight was no doubt the boost phase, exhilarating, super interesting, and yeah, by the time the rocket engine shuts off, you are already outside of the atmosphere, and the moment it shuts down, you're just floating peacefully, and it's, as opposed to this, I wouldn't say fearful, but adventurous and exhilarating experience, you just transition into the probably the most peaceful moment of your life. It was, that transition was also super interesting. So, yeah.
Let me add something about the excitement. Yeah. The fear on the launch pad after you train so long and you're 2 weeks in quarantine and finally get on the rocket. The main fear is that they scrub, that they cancel.
Yeah, there's an easy one to answer here. How do you poop without gravity? It's risky, yeah? We agree, yeah? So, the next one, being an astronaut means...
I thought you were going to answer that.
Being an astronaut means that you are part of a few select people, therefore you often are represented as a role model. How does this affect you in your daily life, and do you ever feel pressure getting to you? And that reminds me of a scene shortly before my flight, because 2 Soyuz cargo rockets crashed into a forest in Plesetsk, and there was a delegation from the German authorities that were doing my flight coming and say, Arnold, you know, if you are now want to bail out of this, we get you out for some financial reason, or we make something up so that you're not the coward who doesn't want to fly on that vehicle. And I was kind of calming them, saying, I'm fine, because I know that the human-rated Soyuz is a completely different vehicle, almost in production and in selection of the best components than the cargo vehicle, and indeed mine worked. So do you think that being put on this public notice does keep you from making a rational decision if you think the risk is too high? Who has been in the shuttle? You have been in the shuttle and in the line of command. So what was the threshold that you would not cross in terms of seeing an obvious risk and still going to launch?
Yeah, I think it's spaceflight's a giant team sport, right? And I worked on some shuttle propulsion teams, and so we were signing certification of flight readiness documents, which is Much tougher job than actually getting on the space shuttle. I was surprised they asked you. I was never asked, "Hey, do you really want to do this?" In fact, even the morning that we woke up before we flew on the space shuttle, like you didn't have to be brave. No, nobody was asking you to make any tough decisions. You just had to follow the crowd, and they all went to a spaceship and got in. So I just followed them along. But when you're when you're in the meetings and reviewing the documentation of the shuttle propulsion elements that were just built, that's tough work. And I think then you're back to Luca's point. You got to do your work, and you got to do it as well as you can. But signing a document for somebody else to fly is a lot tougher than flying.
I actually, if I can take a second on that, on the thought that just happened, I just thought of a moment where I really felt extremely uncomfortable with my capabilities and what I was doing. More probably one of the hardest moment as a flyer, and it had nothing to do with me. It was when I was the IV on the space station, getting ready to send out my crewmates outside for a spacewalk. And the way it works is that the EVs, the EV1 and EV2 going out, you can see the excitement in their eyes. And if you have been in that position, and I have been, you're thinking about the task, about the procedure. You're running it in your head. You're reviewing it in your mind, talking it with EV1 and EV2. They're talking it together. But the IV is doing everything else. They are setting up your suit. They're helping you inside the suit. It's a little bit the squire versus the knight. They're getting you ready to go out into the battle. They are closing your spacesuit. They are checking that everything is correct. They cannot do it. You are checking all the system outside, all their spacesuit connections, making sure that they are not leaking, that they are closely connected. And these are all manual tasks. The ground cannot verify them for you. The crew cannot verify them. You are the only one responsible to make sure that those spacesuits are safe. And even though it's not specifically because it's not your life on the line, but it's your crew's life on the line, letting them out into the unknown, into the void, is a lot harder than being the one going out and getting ready to go. And Aki, you have done this. Can you back it up for me? That is the most uncomfortable moment that you can. One of the most uncomfortable moments you can experience is when you're putting their lives in your hand.
Yeah, absolutely. I 100% agree with what Luca mentioned. So I had the privilege to do 4 spacewalks. I've never actually done IV on orbit. You've done it? Yeah. And I was so glad that it wasn't me, because there's a huge responsibility, you know. You're as an EV crew member, you're depending on the IV crew member.
You've done it,
helping
Tony.
out.
I've only done the IV, so knight and squire, knight only, and squire only. And yeah, when even after you suit them up and just get them out, like the whole time they're outside, you're worrying that like you just want them to finish their work and get back in, and there's no relief like getting them back in and getting that airlock pressurized. But the whole time they're outside, I'm worried more about them than like even sending my kids off to do stuff. It's like
absolutely.
Yeah.
In my little moment of bragging, in my increment, expedition 60, 61, the second one, the second time I was in orbit, we performed 10 EVAs in the time that we were in orbit. 10, which meant that basically every couple of weeks we would be setting up to go outside. And because there are only 4 of us, 2 were going out and 2 were setting them up. Having the second set of eyes, checking that everything that you were doing was correct, was such a relief. And I think that we can add this little thought to the conversation. One thing that is really wonderful about taking a risk is the capability to share that responsibility with somebody else. That load can be crushing, but if you share it, it's a lot better. So I was very grateful to, as an IV, to either being backed up by somebody else or backing up someone before sending out my crewmates. And being the EV, I was really, really grateful for the work that my crews were doing to make sure that I was safe going out.
Yeah,
Vice versa, I remember the scene when they were congregating in front of the hatch and waited for you to come in with a helmet full of water. So all respect for Luca and Aki for their realization of safety in this responsible function.
Yeah. May I add one thing about the increasing risk of obviously walking in space, but of all the space adventures now, there are increasing amount of junk, debris in low Earth orbit. We learned that there are 130 million pieces of metal flying around Earth at 28,000 kilometers per hour, and damage was done to Soyuz, taking it out of operations. A small piece of metal hit the robotic arm of the station. These are disastrous. We have to be aware of that as a space community, that we have to reduce the amount of debris around Earth because it's becoming dangerous. And last year there were 100,000 maneuvers of avoiding such debris or avoiding collision between different spacecrafts. So that is becoming much more difficult, and there's probably necessary to create laws about who cares, how are things sent into space.
Yeah, thanks. We are running almost out of time, but I take the privilege to prolong a little bit. I hope I find your consent. We are not going to sing, by the way. We continue our conversation here. And there comes a fact to my mind. In former times, I think, when you were in NASA buildings, there was always a sign saying their lives relies on you. You, the engineers, you have to guarantee that you put the best piece of hardware on the launch pad, because these are the astronauts, the families, and they all count on you. Antea, spaceflight hardware is more expensive than normal routine hardware. Do you think that this is because you take extra measures also as an engineer to prepare spaceflight hardware in a special way, in a specially guaranteed way?
I mean, it's a set of those things. Not only spaceflight is expensive, also human spaceflight is expensive, also spaceflight of spacecraft, because the space environment is harsher, and there are conditions that are different than the one we have on Earth. And especially, it's not that easy to repair something that fails when it is in space. I mean, it has been done, like with the Space Hubble telescope, the Hubble telescope. Now we are trying to design spacecraft in order to be capable of doing that with robotic missions, but still you want really to validate and verify in depth and detail that your hardware is going to function as it is supposed to function. But actually, since we are not in space, it's even more difficult, because you have to try and find some condition that somehow is similar to what we are going to find in space. So all this process is very, very expensive and long. And when it applies to, when you put a human in the loop, it's even more difficult. First, because we design with different design rules in terms of failure tolerance, etc. And also because you have the human in the loop, which means you also have to add an additional layer of this verification and validation. So it results in expensive missions, but that are worth it.
Thank you. And I want to ask around another last question. It comes from Elias Malki. Thank you. What should be implemented as important safety feature but has not yet been done? A quick round. What you can imagine is a better betterment of what we have today in terms of safety. Who wants to take it first? Okay, we are at the end of this. No. Luca.
Well, I don't know. I feel like when there is no answer, everybody looks at me. But one thing that I think we are working on, but we still need to really focus on and get really better at it, is to putting the human into the spacecraft and the spacesuit before making the spacecraft and the spacesuit. And what I mean by that is that ergonomics is a science today. We have been studying how we move and work in an environment. And yet, I believe that even the newest spacesuit and the ones for exploration, even though they made leaps versus what the Apollo astronauts used and what was available until now, they are they're much better. They are getting better and better. They allow more mobility and less damage to the body. But I think there is always room for improvement. And what I would like to see is a little more imagination into how can we build these extravehicular suits so that they allow us to do more things. We are getting ready to do extensive exploration beyond low Earth orbit. We want to do traverses on the lunar surface. We want to do exploration. We want to perform science. And we are used to we use our bodies in certain ways that are very efficient. And I'm looking forward to seeing equipment like spacesuit and spacecraft that are really ergonomic so that we can get there, perform our tasks the way our body is meant to be used, and not only for certain sizes, but for all the participants of human spaceflight, meaning smaller bodies, longer bodies, taller people, mid people. It's something that we have to work on. And how is that connected to safety? Well, simple. A well-designed ergonomic environment avoids damage and is safer to use, safer to employ. So I think it's a very easy answer. However, I do understand, and please understand that this is extremely hard to implement. So it's just I'm just throwing there a spark of an idea for those students in here and those engineers in here that might have a chance to work on these systems. And sometimes a little spark is enough to ignite a fire of passion, and who knows, maybe they'll be able to come up with that idea that we still haven't had.
And my guess is the question was, what technological advancement or what material science advancement is going to make your individual spaceflight safer. But I'm going to take a different tact and remind us all that fortune favors the bold. So I think the very best thing we can do to be safe with humans flying in space is go much faster. And let's, as long as we're paying attention and learning from it, realize this technique won't make your individual flight safer. So, best of luck to you. But in general, for the future, if we do this more often at a much more increased pace, we pay attention, we're willing to make some mistakes and learn from them. But I think we'll be lucky more often than not, and we should go a lot faster.
Well, to touch upon what Eitan mentioned about having millions of small items, objects, traveling with immense speed in orbit. So we have already had multiple countries shooting down their own satellites just to show that they can. I think to also touch upon the theme of the IAC this year, the sustainability, we have to maintain the pristine environment of space so that beyond making it safe, to make it continue, right? So that we will be launching more and more people, we will be advancing our capabilities in the mid to long term. And to achieve that, we will not do some stupid stuff, and stuff is replaced by something that I'm not allowed to say here, stupid stuff, is to increase dialogue, increase collaboration amongst nations so that we will not do those stupid stuff and mess Earth orbit for the next generations. And the way to achieve that is, yeah, dialogue. Russians are not here today. And I think that's a huge mistake. We need to, one of the things during our training that helped our crew a lot was our NOLS training. It's a survival training, survival and leadership training that we took in the wilderness, right? After that, we had much better dialogue amongst each other. We trusted each other more. I really would love to see those types of wilderness trainings, going out camping with maybe heads of agencies. We can send them on such trips. Increase collaboration, increase interfacing amongst our nations, I think, is the way to keep spaceflight safe for the next generations to come. Thank you.
Thank you. Thea, any ideas there on what is missing in terms of possible safety measures? AI?
The possibility to track very small pieces of debris in space, that would be really helpful because, you know, we're mentioning the collision avoidance maneuver of the ISS that are quite expensive also in terms of fuel, but we can do that with quite relatively big debris, but with smaller one that can still cause catastrophic failures. We cannot do that. So we are just, and I mean, it's not like a possibility. One day it's going to happen with a LEO station because there are so many of those spaces. And if we are better capable to estimate where they are and how they evolve, maybe we will be able to also prevent those type of failures.
Thank you. Aki?
So for low Earth orbit, I think we're doing what we need to do. Obviously, there's still room for improvement, but we talk about the materials, with the design, the backup system, operationally, you're thinking about what the next failure would be, procedure, training, and if something happens and you can't stay there, we can come home. We're that close, right? If we're gonna go further to the moon, to Mars, we don't have that luxury. It's gonna take a couple days to come back. So we need to be thinking about it, and we are thinking about that, how to cope with contingency situations. And so we need to kind of advance our thinking process and think outside the box. It might be a new approach to things. One thing we're talking about, Japan's going to be developing a pressurized rover, but if you go out there and the rover gets stuck, what do? Right? Are you going to make the crew members walk back home, or are you going to depend on a unpressurized vehicle? That kind of thing we're talking about. But we have to think about all the what ifs, and I think we're going to be at the next level of what ifs.
Ethan, your observations?
Well, I would put a doctor or a physician with every crew. Give the crew safety. They can trust someone, and the longer the missions will be to Moon, to Mars, it shifts from a physician to a psychotherapist because the challenges are immense.
Thank you. That wraps up our today's panel. Thank you. I wish you safe travels home. I think this is do not text, yeah, while driving. And we see each other next year in Sydney, I think. Yeah, done deal. Thank you for your patience, and goodbye.